So we're going to do an introductory tour of Multisim. There's a document on Blackboard called Multisim 8 User's Guide, which you might want to look at sometime. I definitely want to print it out. It's far too big to do that. Let's start off this lab by opening the Multisim application now. When you open it up, you're going to see the circuit window where we will build all our schematic diagrams. We'll look through some of the commonly used toolbars. Here's the standard toolbar. And when you see the 3.2.1, that's the reference in the Multisim User's Guide. Here's the main toolbar, and there's that lightning bolt where we can start our simulations by turning on the power or turning off the power as well. Here's the view toolbar. If you're going to use the toggle full screen button, save your work first. And there's a components toolbar, but you can find a lot of the common components just by using the components toolbar. And finally, there's a virtual toolbar, and I think I have an example on the next slide. Let's see if we do. Yes, I do. And for example, in this lab exercise, we're going to use a virtual lamp, so we can find that on the virtual toolbar, and we can place a virtual lamp. We also have an instruments toolbar, which is typically to the right of the capture screen, and it has some test equipment that we're going to use during this course. In today's lab, we're going to use the multimeter, which is right here. So I'll take you through how to do that. If you find that your toolbars are missing, then you can click on the View from the main menu and then Toolbars, and you can see all the different toolbars that you can have displayed across the top of the screen. What we want to do is we're going to build a circuit. We're going to investigate how to build this circuit today, where we're just going to put a battery in the schematic capture, put a ground, and use a multimeter to measure the battery voltage. And throughout this tutorial, you're going to find that I've indicated what the file names you should use when you save these circuits. So we start from a blank schematic capture page. We're going to use a grid to assist us in placing and aligning the components, so we'll select View, Show Grid. And that's what we see now, is here's the grid within the schematic capture area. Let's find the battery now, and we'll place that. You can select components from the database, or you can just click on this ground symbol here, and it will actually bring you up to the same Select a Component menu. We're going to place our components. We'll just place that 12-volt power supply or 12-volt battery someplace on the schematic capture page. And then we're going to rotate it. Have to change the battery voltage because we don't want 12 volts. We only want 1.5 volts. So we're going to double click on that component and change it as illustrated. So now let's find the ground and place it. So we'll select the component. This is our earth ground. This is not a digital ground. We're not dealing with any digital components in this lab exercise, so I do not need this digital ground in this circuit. We'll place it, and now we need the multimeter. So it's likely in the instruments toolbar on the right hand side of the schematic capture area, and I believe it's the top one. So you can find that, and you drag that over. After you click on the multimeter, you're going to drag it over and place it on the schematic capture page. Now we have to wire some components. So I want to connect the multimeter to the battery. I'm going to click on the multimeter lead and then drag that wire down to the battery, and then click again, and it should form the lead. And I'd like you to go ahead and wire the remaining connections now. Okay, now we're all set to set up the multimeter to measure volts DC. What you're going to do is you're going to click on the V and click on this solid line here. That signifies that it is a DC value. It is not an alternating voltage. In the theory class, we talked about measuring voltage, and voltage is measured across a device. Always a good idea to shut the power off before you put a measurement device in a circuit, and also to make sure that the correct setting is selected before you turn on the power. In this case, we want to measure voltage, so I'm going to select V. Okay, now we're ready to turn on the power, and we should see that the display here goes from a blank to 1.5 volts. If it doesn't, you might have to click on that multimeter just to get it in focus on the screen capture. So you should get 1.5 volts, and don't forget to save this. What I have in this particular case here is I do not have the battery connected correctly. What I've done is I've connected the positive lead to the negative terminal of the battery and the negative lead to the positive terminal of the battery. So I've got reverse polarity. In this case, in this meter, what I'm going to see is minus 1.5 volts. In other words, I've made an assumption, the direction of the current, but it's not really going that way, so I'm going to get the minus sign. So what we want to do is we want to be able to show the same sort of thing in Multisim, and you can follow these directions here to do that. Now, with the circuit hooked up like this, you should see minus 1.5 volts because we've got the incorrect polarity here. We've got the negative terminal connected to the positive terminal of the battery, and then positive terminal of the multimeter connected to the negative terminal of the battery. So that's why we get this minus 1.5 volts. And now you can save this circuit. Let's measure some current. Now, don't forget to measure current. The current must pass through the meter. Very important part here. A lot of students get this wrong. Please pay particular attention to this. We're going to have some current come into the meter. It's going to go through the electronics in the meter, and you'll notice that the meter is set up to amps. And then after it goes through the electronics in the meter where it's measured, then the current will flow out of the meter. So here's how we set this up on paper. We have a circuit to be measured. We break the circuit. We note that the current is flowing this way, so it's flowing from the positive terminal of the battery. It's going to flow through the positive terminal of the meter to the negative terminal, through R, and then back to the negative terminal of the battery. What I want to do here is I want to add some resistance to our circuit, and let's measure some current. So you're going to add a 1K ohm resistor, and please note the direction of the battery and subsequently the direction of the current. The current's going to flow from the positive terminal of the battery through the resistor down to ground, and it's going to come up back through ground to the negative terminal of the battery. So that's the direction of the current. So this means that what we're going to have to do is we're going to have to connect this positive terminal of this meter to the positive terminal of the battery there, and then we're going to have to take this negative terminal and connect it to the right hand side of this resistor. Before we do that, after you've made sure that there's no power on, then you're going to click on A for amps because we're going to measure current, and once again it's DC. We have the multimeter set up correctly to measure current, so let's take a look and see where the current's going. If we have the positive terminal of the battery, you can see that the current's going to go up through the positive terminal of the multimeter, through the electronics inside the multimeter, out the negative terminal of the multimeter, and to the right hand side of the resistor, through the resistor, down to ground, back up from ground, and back to the negative terminal of the battery. Now you can turn this on, and you will see that we get 1.5 milliamps of current. So that means it's 1.5 times 10 to the negative 3 amps of current. But we use engineering notation, which the M, the small m, stands for milli. That stands for milli right there, and that's how we write that. Let's take a look at some switches. Switches in simple circuits. If the switch is in this position here, it is open, which means that there is no current flow because there is no path for the current to go from the positive terminal of the battery around the circuit and to the negative terminal of the battery. So there's no complete loop. So we call this an open loop. In this case down here, we have a closed loop. The switch is closed and the current will go from the positive terminal of the battery through the switch, through the lamp, and back to the negative terminal. So this is a closed loop, and you'll also notice that in the open loop, of course, the lamp is not on, and in the closed loop, because there is current flowing, the lamp is on. We build this in Multisim, and you'll see that there is no current flowing here because the circuit is an open loop. Conversely, if I close the switch by pressing on the A key, then we have a current path from the top of the battery, the positive terminal, through the lamp, through the switch, down to ground, from ground to the negative terminal of the battery. So we have a closed loop. So I'd like you to build this circuit now in Multisim. This lamp is located on the Virtual Components toolbar. And test it, and once you're finished, save it. We also briefly discussed fuses in class the other days. Here's a repeat of some of the things here. And what we're going to do is investigate what a fuse does. We have projectors in our e-learning classrooms, and the bulbs in those are quite expensive. I think they're around $1,000 a piece, maybe $1,200. But let's see what happens if the electronics in the circuit is not correct. Simulating that here, I have a 40 volt battery, I have a 47 ohm resistor, I have my lamp, and I have a closed loop because my switch is closed. And that means that the current can flow from top of the battery, the positive terminal, through R1, through this lamp, through the switch, down to ground, back up from ground, and to the negative terminal of the battery. But what's happened here is that I guess there's too much current in this circuit because sometime later we have burnt this lamp out. There's $1,200 or $1,000 down the drain, so we have to do something to prevent that. What I would like you to do is, after you save your previous circuit, change its configuration as shown and test it and observe that the lamp burns out. What we're going to do is we're going to put fuse in here. And the fuse is rated at 1/4 of an amp, which is 0.25 amps. And we're going to see the effect of putting this 5-cent fuse in the circuit that contains a $1,000 lamp. We're going to leave the other components the same. We're going to keep the battery at 40 volts. We're going to keep the resistance of the resistor here at 47 ohms. And we're going to have a closed loop with a fuse in it. What's going to happen, instead of the lamp burning out, then after a little bit of time the fuse will blow or it will open. So now, instead of having a closed loop, even though the switch is still closed here, we have an open loop because there's a gap here where the fuse used to be a solid link.